Welcome back, brave souls, to Lumon Radio, a tutorial on CSI Linux and OSINT. It's time to take a plunge into the depths of the internet. I'm on some visage, your guide through the shadows, and this is brought to you by CSI Linux. You better prepare yourself for this episode, because today we are descending into the abyss of the internet's darkest corners. Just like Artorias, except we're not gonna fail and lie about it. We're going deep into the rabbit hole, the dark web. Grab your darkest sense of humor, because you're either gonna laugh or wet yourself, and not in a good way. We're about to explore a world where anonymity is the key and OPSEC is a must. But first, we gotta understand how the dark web works. So first things first, let's shed some light on the dark web. It's like the secret club of the internet, where you need an invite just to get in. Like the surface web at my little nephew's b-day party, which is as innocent as a grandma asking the Google search engine to bring up google.com. The dark web is the haunted house of the internet. And no, there ain't gonna be a bipolar, edgy teenager ghost protecting you like that show. But remember, you are responsible for every action that you take, and the consequences will follow. Picture the surface web as an apartment, where everything is in plain sight. The deep web, well, that's your basement, filled with personal stuff, and a trash can full of other stuff that you don't let your mommy get close to it, because you know what you have done. Well, that would be the dark web. The analogy is all correct, but one aspect. The dark web is way, way bigger than the surface web. To be more actual, dark web is a part of the vast space of the deep web, where some doors are just hidden by your normal search engine, and the rest cannot be found unless by using a special code decryptor and special browsers and protocols to decode the address. Why do we need it? So many different purposes, and one reason, because we don't like surveillance. Now, what makes the dark web truly unique? It's its ability to hide in plain sight and be invisible, like Batman or you in front of your crush. Let's say you've got an address, but just by simply having something doesn't mean you get to use it. Virgins know what I'm talking about. And that's where the onion routing comes to save the day. Digital-wise speaking, of course. Be realistic. Nothing's that powerful to help you not be a loser. Onion links and onion routing. Onion links and onion routing are the backbone of anonymity on the dark web. Remember that. Let's talk obvious. One of the first things you encounter would be the address. Instead of a regular URL like www.example.com or .org or .net or whatever, you'll find something like this. This onion link is your gateway to the wonderland. Now here's where the magic really happens. The onion routing. Imagine your internet connection as a package, as we've discussed already, that you want to send to the onion link, instead of sending it directly, Tor does something genius. Tor takes your package and wraps it in multiple layers, like an onion. Each layer has a unique encryption, and each layer is peeled off at a different Tor node along the way, where on each layer only the point A and point B are known. The next layer would have its own points, C and D. A bit of the architecture. The Tor or the onion router network is designed to ensure anonymity and privacy online. It achieves this by directing internet traffic through a free worldwide well-interior operated network consisting of more than 7,000 relays. The structure of the Tor network is complex and is based on the principle of onion routing. Let's talk about these nodes. Entry or guard relay, the first point of contact for a user entering the Tor network. These nodes can see the user's real IP address, but not their activity or the final destination of their data. Guard nodes are publicly listed and change for each user approximately every 2 or 3 months. Middle relay. These nodes form the largest portion of the Tor circuit. They pass data in an encrypted format, knowing only the identity of the immediately preceding and following nodes in the circuit, not the entire path. Middle relays neither know the source nor the final destination of the data, ensuring added privacy. Exit relay. The final relay where data leaves the Tor network and enters the public internet. The exit relay decrypts the data and sends it to the final destination. These nodes can see the data being sent unless it's encrypted, but they don't know the original source of the data. Bridge relay. Specialized relays not listed in the public Tor directory, used in areas where access to the Tor network is blocked or monitored. They are the first point of contact instead of the usual entry or guard relay in such scenarios. Their use makes it more difficult for governments or organizations to block or detect Tor usage. Tor circuits. A Tor circuit is a path of encrypted connection through the Tor network. It typically consists of 3 nodes. an entry or guard relay, one or more middle relays, and an exit relay. The data is encapsulated in several layers of encryption, like an onion, and each relay peels away one layer, uncovering routing instructions for the next relay. The path is randomly generated and can change for different browsing sessions or at regular intervals during a session. No single relay ever knows the complete path of a data, which is fundamental to ensuring the privacy and anonymity of the user. Encryption in Tor. Tor uses layered encryption. Each relay decrypts only enough to know where to send the data next. The final layer of encryption is removed by the exit node, revealing the data necessary for the destination server. Dynamic nature of circuits. Tor circuits are not static and can change periodically. This dynamic change adds another layer of security, making it even more difficult to trace the user's activity back to them. And trust me, you would definitely need that. A bit in Tor address variations. Prepare yourself for a lot of awesome and detailed info. Well, who am I kidding? You're just going to skip my wonderful monologue that I've spent hours to write and just take a screenshot anyways. So here you go. A summary, a cheat sheet, your cheap burger. Hey, 1 medium latte for these nuts. These nuts? You get my point. Anyhow, where was I? Oh yes. Tor makes it incredibly hard for anyone, even the most determined snoop, to trace your online journey. Did you know that Tor browser even changes the size of the browser's window? Because even your monitor's resolution is a footprint for those who know where or what to look for. To get started, just simply type torproject.org and download the browser. Although CSI Linux will provide you with a built-in Tor VPN, most secure than ever. Thank you, CSI Linux. Now, all that has to be done is you booting up your CSI, clicking on that, entering the password obviously, choosing a network adapter and making sure it's giving you an IP, then waiting for the thing to do its thing, obviously choosing the on button. And voila, you are now connected to our Tor VPN and the footprints are no more. Now, just because we're awesome and you deserve some desserts, just click on "What is my IP" on that corner and witness the eternal sunshine of a spotless mind. Look at the cool details. You look like a hacker already. Now you can head up to cool websites for your weekly purchases, kitchen tools, exotic seasonings, whatever you need for an awesome dinner party with your grandma. Because nobody came, and your grandma is deeply empathetic. Whoop whoop! Now maybe Tor isn't what you need. Maybe it's just not your taste, which makes me question your taste. It's always good to have some alternatives, right? There are some decent alternatives out there, some with different purposes, and there is a whole world of dark web protocols you should be aware of in your use and investigations. Now let's unveil a bunch of hidden gems of the web. Freenet. Well, Freenet is a decentralized peer-to-peer network and software platform created by Ian Clark in 1999. It was designed to provide secure and anonymous data sharing and communication in response to concerns about online censorship and privacy violations. Freenet operates by splitting data into encrypted chunks and distributing them across a network of interconnected nodes, ensuring anonymity and resistance to censorship. Its primary use is for sharing information while protecting user identities and data. ZeroNet. ZeroNet is also a decentralized network and software project developed by Thomas, whatever his last name is. You know what? We only pronounce American names. Take that, rest of the world. America, fuck yeah! Coming again to save the motherfucking day, yeah, America! Fuck yeah! Freedom is the only way, yeah. ZeroNet allows users to create websites and applications that are stored and served from a distributed network of peers, eliminating the need for traditional web hosting. This decentralized approach ensures that websites on ZeroNet are censorship resistant, as they are not hosted on central servers. Users can access ZeroNet content using the ZeroNet software, which connects to peers to retrieve and display website data. This design makes it difficult for authorities to censor censor or take down websites, promoting online freedom and resilience against censorship. Well, you get the idea. So let's have the rest as well. I2P, or Invisible Internet Project. I2P is an anonymous and secure online communication network developed in the early 2000s by a group of developers. Who, you might ask? Well, you can always Google. LokiNet. It's a privacy-focused internet browsing and communication network created in 2018 by the company Loki. GNUnet. GNUnet is a secure and censorship-resistant networking ecosystem initiated in 2001, led by Christian Grothoff. OneSwarm is a privacy-oriented file-sharing system developed in the late 2000s by the researchers at the University of Washington, led by Michael whatever his last name is.
That was way out of line.
I'm sorry, did you have to cut it off?
Of course I have to fucking cut it off.
I'm sorry.
Fuck you. Jesus. What's wrong with you, asshole? What do you mean? Get your shit together. Put them in a bag and put them all together. Oh, gee.
Well, I'm really, really sorry.
Shut the fuck up, asshole. We're fucked.
Really, really sorry.
Wait, fuck. Is that shit still on?